Hey there, and welcome. You know, the everyday items around us, from the sour lemon juice sitting in our kitchens to the soapy cleansers in our bathrooms, are actually locked in an invisible chemical battle. Today, we're going to uncover exactly how this microscopic clash works. Okay, let's dive into this breakdown. First up, we'll look at acids versus bases. Then, nature's chemical detectives. After that, we'll tackle the neutralization reaction. And finally, everyday chemistry rescues. All right, Section 1, acids versus bases, the chemical opposites. Now, what's really interesting about this slide is how it grounds abstract science right into our everyday sensory experiences. Think about acids. They are absolutely packed with hydrogen ions, and they give us that sharp, sour bite, like lemon juice or vinegar. On the flip side, we have bases. Bases are rich in hydroxide ions. They feel slippery, kind of soapy, and they taste really bitter. And it's exactly this chemical duality that flips the color of litmus paper. So acidic properties will turn blue litmus red, while basic properties do the exact opposite, turning red litmus blue. But hey, what happens if a substance doesn't fit into either of those extremes? Well, that brings us to neutral substances, matter that is neither acidic nor basic. Pure water is pretty much the perfect anchor point for this. It doesn't taste sour, it definitely doesn't feel soapy, and it won't change the color of litmus paper at all. It just sits perfectly in that peaceful middle ground between our two chemical opposites. Now, you might be wondering, how do we actually test these? Because, let's be real, relying on taste and touch to classify unknown chemicals is obviously a massive safety hazard. Please don't do that. We need a rock-solid way to uncover chemical identities from a safe distance, without putting ourselves at risk. Which leads us straight into Section 2, Nature's Chemical Detectives, Uncovering the Invisible. So, to solve our testing problem, we rely on indicators. And this brilliantly illustrates how we stay safe. These are substances that specifically change color to show us whether a substance is acidic or basic. It's like a built-in alarm system. A simple, dramatic color shift acts as our highly visual, totally safe chemical detector. We don't have to touch or taste a thing, we just let the indicator do all the work and watch the colors change. And nature provides some truly amazing chemical tools to pull this off. Take litmus, for example. It's actually a natural dye obtained from crusty lichens growing on rocks, and it shifts from red in an acid to blue in a base. Or just look in your pantry. Yellow turmeric instantly turns reddish-brown the second it hits a base. The China rose is another cool one, pulling off a massive visual shift from dark pink in an acid to a vibrant green in a base. And then there's phenolphthalein. This is a synthetic lab indicator that stays completely colorless in acid, but flash it with a base and boom, it turns a shocking pink. Moving right along to Section 3, the neutralization reaction, when opposites collide. So what happens when our red-turning acids and blue-turning bases finally meet face-to-face? Well, we get neutralization. So the crucial point is that this is the reaction between an acid and a base to form salt and water. At a molecular level, it's like a tiny battle where those fierce opposing hydrogen and hydroxide ions completely cancel each other out. Their chemical clash literally destroys their defining properties, leaving behind nothing but neutral water and a harmless salt. It's a real game changer. And that brings us to our final part, Section 4, Everyday Chemistry Rescues, Neutralization in Action. Let's actually look at how this plays out to save the day in the real world. Step 1, treating ant bites. Did you know an ant actually injects acid directly into your skin? Ouch, right? But if you apply a mild base, like everyday baking soda, you neutralize that acid for almost instant relief. Step 2 takes us out to the farm with soil treatment. Crops are incredibly sensitive to the chemistry of the dirt they grow in. If a farmer's soil becomes way too acidic, they can rescue their harvest by adding a base, like quicklime, to neutralize it. On the flip side, if the soil is too basic, adding organic matter will naturally release acids to bring the earth back into a healthy, neutral balance. And finally, Step 3, factory wastes. Industrial wastes are often loaded with really dangerous acids or bases. If those were dumped directly into our rivers, the ecological damage would be absolutely catastrophic. Instead, factories treat these liquid wastes with counteracting chemicals to neutralize them, essentially forcing them to turn into safe salt and water before they are ever released into our waterways. It is genuinely incredible how much of our daily world relies on balancing these unseen forces. We've seen how acids and bases stand as total chemical opposites, how nature gives us these amazing, colorful indicators to track them down safely, And now the power of neutralization keeps everything from our own skin to our environment perfectly safe. Armed with this knowledge of how molecules clash and cancel each other out, I want to leave you with this. What other invisible chemical battles are happening in your world right now? Keep your eyes open and keep questioning what's going on beneath the surface. Thanks so much for joining me as we explored this topic.